Okay. A simple way to understand compounding interest is to think of it as the interest you earn on interest. To help explain, let's say you put $1,000 into a savings account which will earn 5% interest in a period of 1 year. So by the end of the year, you've got $1,050 because, of course, 5% of $1,000 we know to be $50. You also earn interest in the second year, assuming you don't raid your bank. However, this time you start the period of $1,050 in your bank, so you earn interest on the new present value. We'll talk about that in a bit. This means the initial interest is compounded and you earn $52.50 in the second year. This difference of $2.50 may not seem significant at first, but leave your bank for, say, 40 years, and you'll see your new bank balance is $7,039.99. Unfortunately, this applies to debt as well, and the money you owe creditors will gain interest and increase. Let's take a look at calculating these rates. To do this, we'll utilize the compound interest formula. So, A equals P multiplied by 1 plus I to the exponent n. A is our accumulated or future value. The accumulated value is what we get after all the compounding periods. The equals sign means equivalent or equal to. P is our principal or present value. In the situation described before, the initial $1,000 would be our principal value. The 1 maintains our principal value, so we don't end up multiplying accumulated interest versus our new present values. I is important. This is our interest rate. It's important to understand that when we're given an interest rate of 9%, I is not equal to 9, but 0.09. Okay. This is because a percentage is also a fraction. 9% of any whole can be represented as a decimal value under 1. It's equally as important to understand that I is the interest rate for any given compounding period. A rate of 9% per annum compounding monthly is not 9% every compounding period within a year, but rather 0.09 divided by 12, compounding 12 times per year. Okay. Finally, our exponent n. This is equal to the number of compounding periods. If you're looking at monthly compounding periods over 3 years, that means n is equal to 36. Let's see how we do with a sample problem. Here at the Bank of Wizardly Convenience, we offer an 8% compound interest rate per annum with a 6-month period. The only catch? We hold your money for 50 years. Supposing you deposited $1,000, what's the total amount of interest earned after 50 years? And what would it look like on a graph? I'll give you guys a moment. Just pause the video. Let's see if you were right. Our principal amount, P, would equal the initial deposit of $1,000. If our annual interest rate is 8% and is compounding every 6 months, I should equal 0.04 or 4%. And since n is equal to the amount of periods, we'll put it at 100. 2 times per year, 50 years, you get the idea. Now we're looking at a future value and new bank balance of $50,504.95. Is that what you got? Let's hope. But remember our question. We need the total amount of interest earned. So we take the new bank balance and we subtract our initial value. So the total amount of interest earned is therefore $49,504.95. Here's our graph. So what do I get for solving all of that math?
This!
Oh, God!
Out of it.